So I know you might be knowing about the today's topic. I hope earlier the interpretable machine learning was planned in this room, but now the topic has changed since Prof was not available. So yeah, meet Rishabh. He is a man with multi talents. So be it I mean by profession he is a software developer, and he is the man behind our Seek portal. So he might be sharing about his personal journey and all. So okay, yeah, maybe he can say.
Hi everyone, nice to meet you all. I'm Rishabh. So yeah, I have been the one of the software architects of the NPTEL and then later on Seek portal, just developing the backend and infrastructure behind it. Yeah, so just going to talk about a little about my journey, about how I reached here, what I challenges I faced, about my coding journey, and then we'll do some interactions about your coding journey, how you all got into coding, what it means to all of us. And then towards the end, I have a small challenge for all of us. We can do it on our phones, completely optional. If you want to do it, you do it. If you don't want to, that's fine. Yeah. So I actually got into coding when I was very young, when my dad would get a computer from office, and I would play computer games on that when I was, I think, 6 or 7 years old. And so that's how I got into computers. Was a gamer kid, very addicted to technology and everything. And I think in school, in about ninth standard, I took my first coding class. Very basic Java programming, boring applications we had to build. But that just sparked some interest, and then I started playing around, searched the internet about what coding is, what languages are, and I think the next 4 or 5 years I just spent hacking into my own devices, like doing something on Windows, it would stop booting, fix it, install Linux, that would get spoiled, fix it. So it was a very hack and learn journey. Google search, figure out how to do it. Yeah, and worked on some small projects on the side. So I think in 11th and 12th, my parents' biggest complaint would be you're spending too much time on the computer. Yeah, I think now that has been much more normalized. Everybody spends time on the computer now. So yeah, and then what? Then I got a coding job, which was much more boring as compared to the playing around that I would do. Uh, yeah, but you get used to it. I think after then I quit the job. I didn't like it. I spent some 6 more months trying to figure out what I want to do with life. Then I realized no, I probably just still want to code. Got back into another job. Then I slowly started liking the coding in the job a lot more. And I think in 2015, 16ish, 15, yeah, I started working on the NPTEL portal, which was a lot of fun. It was a different scale altogether. Like it actually started with just one course on NPTEL, and within I think the next 2 years, it went to some 20, 30, 100 courses, and went from like 1,000, 2,000 students to like 1 lakh students. And yeah, that was a very, very high pressure, intense experience where anything that I would code, if let's say a small bug or something goes out into production, instantly I'd get feedback from thousands of students. Like, oh, this is not working, that is not working. And then the next 2, 3 days would go in high pressure mode just trying to fix that. So I think even over the last 8, 10 years, I've learned a lot about scale and just how to not make such stupid mistakes, especially when you're writing code for so many number of people altogether. Yeah, 1 second. I just keep this in my hand. That's easier. Yeah. So yeah, a few just random interesting things about my journey is one is how I learned how to code. Of course, after the initial subject that I spoke about, I actually didn't know how to code back then. I just was able to do the assignment somehow. I didn't understand why my code worked and what it was doing. It just worked and I got the marks. But I actually learned how to code after that when I learned Python. And I remember this one night, I was just Googling the internet, came across Python, came across a YouTube series about Python. And I started at 7 p.m. and I think till 7 a.m. I was just watching that YouTube series. And it's actually a very simple language to learn. No complications, nothing. And at 7 a.m., I had written a small, very small, tiny program which ran successfully. I knew what it was doing. And it was very surprising and fascinating that just watching videos and just experimenting yourself. So you have the Python interpreter, yeah. Just keep on giving commands and experiment yourself, and you can learn so much just from that. Yeah, but it is important to experiment. So I think you shouldn't be afraid to just go and do things because the computer is a very safe environment, right? Of course, assuming you don't run code to delete your files and stuff like that. Yeah, so it's a safe environment. You can do whatever you want. There are very low repercussions. Nothing will go wrong. Worst case, your computer will get spoiled. Do a restore, it will work again. So there's very less that can go wrong. So most people that I meet now are afraid to run code that they don't know what it'll do. And yeah, that is one thing. The second thing is, I think this is something I want to ask all of us, right? Why do you code? Anybody wants to answer? Like, what is your objective for coding? Yeah, I mean, what problems? Where do you get the problems from? Customers, yes, yes, yes. So yes, for finding solutions, that is one objective. Any other objective that you might have? I mean, I can think of like four, five. Yes, that is similar. So if you're solving problems, you're making your life easy, right? Yeah. Like one simple answer a lot of people might give is for making money, right? It's big in the industry right now. So you might code to make money, which I think is a valid reason. We shouldn't keep that aside. A lot of times when people promote coding, they say it should not be for the money, it should be for a lot of other reasons. But I think money is also a component in it. It is big in the industry, and which is okay. The other thing that might be is for fun, like you might enjoy coding. Like for me, at least when I started learning, that was a very big part of it. There was no real problems I had to solve. And I didn't even know coding was for solving problems. It just writes something, it does what you tell it to do. That was interesting. So I think in the long run, fun should be at least some component of why you code, right? Because if you enjoy what you're doing, then it just makes it easier to spend those hours grinding at it, bug fixing or whatever. Because honestly, it's not the easiest thing to do when you code something and it fails and you have no idea what you have to do. I mean, you just have to sit there breaking your head for several hours figuring out the solution. And if it's absolutely no fun, then you will burn out and feel like not doing it. So yeah, I think just figuring out what style of coding or what in the software world is fun for you is good to do. Right. So you might like right now in the industry there are several fields inside coding itself. You can be a data engineer, you can be a front end engineer, back end engineer, you can be ML AI specialist. So if you find out what interests you the most, I think that'll take you the farthest. Because then yeah, it just gives you that extra juice to continue going. Yeah, that was one. And I think yeah, the other thing I already covered is don't be afraid to experiment. In technology, right, the technology is evolving at such a fast pace. Even right now, I think if I'm not constantly up to date with the new forms of tech, in like months, I feel outdated. Like I might know something today, 6 months later, something new might come up. And if I'm not up to date with it, then I feel lost. Like the biggest development in the last few years has been generative AI. And till like 2 years back, I would code everything myself. Now, 70% of the times, I just formulate my requirements, use an AI assistant to give some boilerplate code for me, edit that, test it out, and then put that in. This gets us to another very frequently asked question is, will AI replace coders? I don't think so, because right now, at least for the next 3, 4 years, um, we can't trust AI 100%. So I think the people who can use AI will be coders themselves for coding. So if somebody does not know coding, they will not be able to use AI to generate code, use it on production, and make sure it's correct. So it's important to know what you're doing. And AI or ChatGPT or something is like your dumb assistant who can understand what you're saying, can do things for you, but doesn't know context of anything at all. So it's on us to verify the output and what's happening and whether it's okay or not. But all that said, it's a very powerful assistant. So yeah, I think we should use it left, right, center, exploit the technology that we have to make our lives easier. Ultimately, we're coding for that reason, right? To make our and other people's lives easier. Technology, the role of technology is to make life easier. So if we have some tools, then why not use them? Yeah. Yeah. And so we'll go back to the Seek or NPTEL portal for a little bit. Yeah. Tell me.
You just told that if you don't keep
Yeah.
yourself updated, you feel yourself lost.
Yeah.
So what resource you are using to keep yourself updated?
Yeah, that is.
Because there are so many
Yeah,
resources
yeah.
you get lost in that also.
Yes, that
There
is
are so
correct.
many YouTube channels
Yeah.
and all that. So that is also a problem.
Yeah. Yeah. Yeah, resources, right? Definitely. So I think you're right. There's so much information available on the internet, right? If you go for all of it, you will get lost. So I think step one would be to just follow some newsletters, some blog posts about general tech, which give you the big achievements in technology. So, for example, as ChatGPT became big, it was featured in almost all of the tech newspapers, tech journals, blogs, etc. So, yeah, if enough number of people use some technology, it will get featured in the big journals, and then you will know about it. Then you can decide whether you want to learn it or not learn it, which is your choice, depending on your field, on your interests, and everything. So that is the first step. Second is, I think I do a lot of these small hobby projects. So approximately 20% of my coding time, 30% of my coding time goes in projects which are outside my profession. And whenever I do a hobby project, I try to use technology which I don't know. So like if I'm writing a new piece of software, as step one, I will go and do a Google search about what the latest tech is to write that software or to solve that problem, and then learn it and then use it. So that's a very good way. And the projects are since these are your own projects, right? So they're not a very low impact. Doesn't matter if you mess it up. So you get much more scope to experiment and learn and keep up. So yeah, I think these two are great. So this is how I learned. After Python, hobby projects, how I learned all the other languages: JavaScript, TypeScript, Angular frameworks, random frameworks, whatever. So now I'm thinking of starting to learn Golang because yeah, why not? Yeah, hope that answers your question. Yeah. So yeah, if we go back to the Seek portal, right? So before I dive into the details, do you guys have any questions or are you curious about anything about the portal? So how many of you have used the like? So all of you must have given MCQs and short answer questions on the portal, right? How many of you have done, for example, programming assignments on the portal? Everyone? Yeah. So So actually, that is one component I am very proud of. It was fairly challenging to build when I built it long back. This was back in NPTEL. And I remember when I started off, so we had to run some piece of code which a student submits on the servers, and there were so many security implications to that. Like you don't know what code the student's submitting, you have no idea where it's going to run, what's going to happen. For all we know, somebody might hack into the entire system, and you're giving them a lot of freedom, the students. So there's so many new concepts that I had to relearn, which I had learned back in college many years back, about operating system, security, the Linux kernel, how it operates, network level security, and everything. So I remember those 1 or 2 weeks of just architecting that, and yeah, it was just filled with what do I do next? And I know I'd learned this in college, and so this gets me to another interesting point where a lot of the theory that we learn in university, we don't use it most of the time in coding because the problems that we solve usually are very simple. But that one time in maybe 3 4 years where you face a more technical or more challenging problem, I think all the concepts come in. So it is helpful to pay attention and learn the theory when you're learning it, because I don't think once you're out of the engineering program, I don't think you will ever go back and sit and learn the theory. Like right now, I wouldn't sit and read a book about operating systems. But whatever is there, when I face a problem, it comes back slowly, and that's very helpful in handling some of the edge cases where otherwise I would eventually understand. Like you play around enough, you experiment enough, you'll eventually learn anything in software. That's I think the best part about software engineering compared to a lot of other fields, is that you have like an infinite playground where you can just experiment and learn yourself. But yeah, when you know the theory, it just speeds up the process. It would have taken me 6 months to make that component if I had not known some of the security theory about operating systems and just network concepts, etc. Yeah, and yeah. So one another question is like people ask me what are the best part about developing the NPTEL, working for the NPTEL portal or the Seek portal. I think for me, the best part has been just the scale and the impact of it. Yeah, I think last when I moved from actively working on the NPTEL portal to the online degree portal, NPTEL had, I think, some several lakhs of students giving exams, taking the courses, and yeah, anything that I would develop would get used by so many students. You see the feedback, you see that it's impacting people's lives. I think that was a big reason for me to stick around. So yeah, so to backtrack a little, I worked with the NPTEL or the IIT Madras team till 2000 and from 16 to 20, 21. And then in 21, I moved out. I worked for two other startups for 1 year each. And then recently, 6 months back, I came back in. And yeah, now I'm working part time with them. But yeah, still architecting and developing on their tech. So yeah, I think in those 2 years in between, I really missed the importance of the work that I was doing. The other startups, they were paying more, but the work was just developing websites or mobile applications for some random cause I didn't believe in that much. And yeah, having worked with education for so long, this was had become very close to my heart. So yeah, I think along with making sure the work is fun, I think having a reason to do your work also plays a role for a lot of people. If you like in when you're feeling low and don't want to work. If you don't have a reason to get up and work, I think it just gets more difficult. Yeah. What else? So yeah, I will move on to some other topics about uh, production grade code versus when I'm learning how to code. This is another topic that I've seen people struggle with is people when they're coding for themselves or just for fun, it's fine. They're able to manage. But when it comes to actually pushing their code to production grade, or or even a simpler version of that is when people get into companies to code. Sometimes they struggle a little bit into keeping up with the both the pressure and the standards of the code that you need to succeed in companies. But yeah, before I go into that, when it comes to Seek or anything else that I've spoken, do we have any questions?
So it's a good practice to practice this codes on lead code platforms like lead code.
Lead codes, yes, interesting, yes. Definitely, I think the objective answer to that question is yes. But what I would add is I think that shouldn't be your only way of practicing coding. So, lead code or any of these online coding algorithms, data structures, platforms, they train you in a very specific, narrow way of coding. So they'll improve your data structures, algorithms, and overall problem solving skills. But what they will not help with is when you're provided with a complete problem, how to design solutions for that. And when you face roadblocks which are not 100% coding related, right? So you might be developing a software, and you suddenly see that your software does not run on somebody's computer. That has nothing to do with the algorithms you wrote. So how do you tackle that, right? So I think lead code is definitely helpful. It is one of the best platforms to improve your aptitude and problem solving skills. Yeah, but also take up projects and whatever the project is, like end to end solutions, right? End to end solutions which are not just small pieces of code. I think both combined will help a lot. Yeah. Yeah.
Those person who are not coding background,
Hmm.
how to start and which platform they should spend time so that
Right.
they can start work in the coding field.
Right. Yeah, this is a very good question. Um, I think if uh, when it comes to coding, right, there are broadly two aspects to it. One is the technicalities of the language that you code in, and the other is the thought process or the logic that you write. Right. I think when you're starting off, the technicalities become a slightly bigger hurdle. Okay, so I would say pick up languages in which the technicalities are low as your first language. So Python is a great choice, right? Go is a great choice. These two are, I think, two of my favorite languages right now. If you pick up something like Java or C++, just do a small, to solve a small problem, you'll have to write like 100 lines of code, out of which 90 are just Java specific. It's not specific to the problem you're solving. So yeah, I think pick up Python or something. And second, how to start with Python, for example. There are many courses and video courses, not graded, like just 20-hour courses. Like you spend 20 hours watching videos, and while you're watching the videos, you code. So there are many video series specifically designed for this. So I would say start with that. It'll give you an introduction to how Python works, how programming languages work, and just give you a feel of it. So that is the best starting point. So I learned with a YouTube series, which is now is very old. So now there are much better ones. You can go to, like, for example, forgetting, there's one. somethingawesome.com. Let me see if I can find it. Okay, I don't remember the link, but I can look for it and send it across. Basically, like a 10, 15-hour course where every course they teach you some concepts, they give you some small assignments to solve, and you can do it right there and then. And I think in a week, you should be comfortable enough to take up more projects. I think once you cross that first hurdle, right, of the unknown, like when somebody doesn't know how to code, they look at code and it looks scary. Once you cross that first hurdle and it stops looking scary and you know like, oh, okay, this is something that I can read and understand, and when I run it, it will do what I'm telling it to do, nothing else. After that, it becomes much easier. Then you pick up projects, and of course all of you all have introduction to Python course here. Yes, yes, yes. So yeah, I haven't seen the contents of that course, but I presume that will also be okay. Yeah, you should probably just so other thing about here is, right, you just ask the instructors that you want some content in which you can play around with more.
use in that industry.
Hmm.
Like learning the Python
Yeah,
this program is not sufficient to start
yeah, yeah. So that will take some time. So the first step, so the thing is, the code that you write in the industry, that will come a little later. So you have to go through the first few steps of the boring, pointless uh, hello world programs or addition. You build a calculator or something. So these you will never use in production. But once you learn them, then you can use those concepts to build other more complicated codes. And have you started with the app development course here?
this term I have taken.
Right, right, right. So that should teach you a lot of concepts which will actually be used in production. So because what happens in so many of these smaller things that we build, right, have already been built by people. So when it comes to solving real world problems, we don't want to rebuild those. So we use software which has already been built by people, and then just write the core logic of what we want our software to do.
So basis of the problem statement,
Yes.
then use already made.
Yes, 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 yes. But when you're learning, you need to learn how to build the modules as well, right? Yeah. So that's the thing. I think don't worry about whether what you're learning is actually useful or not. As long as you're learning something, it's fine. And after a few months, you will reach a point where you're confident enough that you'll say that, oh no, I know how to do this. Now I want to learn something which I actually want to use. So that will happen organically. Yeah. Thank you. Yeah.
Database technology you are using is NPTL. Like if you want to, if someone tell you to rebuild this project now,
Hmm.
do you have any idea like you want to change the technology?
Oh, interesting.
Yeah.
Yeah, yeah, yeah. Interesting. Yes. So the question is which tech I'm using right now, database technology, and in general for the NPTEL project, and if I had to rebuild it, will I change anything? Right. So right now the database we're using is a NoSQL database, a proprietary Google Cloud NoSQL database, the data store, and it's very similar to any other NoSQL database. But the thing with NoSQL is they're not very standardized, right? So the concepts are similar. You don't have any joins, you don't have tables, you just have JSON objects, and yeah, no foreign keys, nothing. So I think if I had to rebuild it right now, so this is not to say that I would have built it differently back then, because now the project has matured a lot over the last 10 years. I would go with SQL instead of NoSQL. A couple of reasons for that. One is, so do we know why we select NoSQL over SQL or the other way around? How many of us have an idea? Yeah, yeah, yes. Yeah. Yeah, I think that is the biggest reason. And the other thing is the horizontal scaling, right? I think till few years back, SQL did not support horizontal scaling. But now you have products like Google Cloud has Cloud SQL, which advertises horizontal scaling very seamlessly. So I don't know the internals of how they cracked it, but it's much easier than it was a few years back. So earlier, if you had one SQL instance, the space was fixed, and if you had to increase the space, you would have to do a migration, get a new SQL instance with bigger space. All of that is not needed anymore. With the managed instances, it manages automatically. So, yeah, the tech has also evolved in the last 10 years, right? Yeah. So, and the product has matured enough that our data is now, data structure is very stable. Yes, yes. So these are some proprietary tech. Google Cloud SQL advertises that they scale up and down much faster than traditional SQL instances. It's like auto scaling managed SQL cloud. I don't think if we self host it, it's still not possible. But it will be in a few years, I think. It might not be so. It might not be horizontal scaling in the traditional sense. In that you have one disk, you attach another disk, and it attaches automatically. It may or may not be that. I don't know. What might actually be happening is the migration from one disk to a bigger disk is more seamless. So horizontal scaling might be happening at a disk level, not at a SQL level, right? So with for example, GPT partitions coming in, resizing disks is very easy, and a lot of these cloud systems actually just have virtual disks; they're not physical disks. So if we say that we want a 100 GB disk, and then tomorrow we want to resize it to 200 GB, that resizing process will happen in like 30 seconds. So I'm not aware of how the horizontal scaling is working, but I know that from a cloud solution point of view, it has been cracked.
What are the issue you are facing that you
With NoSQL,
NoSQL that you are thinking that it might
data analytics is a little hard. We have so much data, and we want to analyze across courses, across students, look at some patterns. Uh, just not being able to query on the NoSQL database. So whenever we do data analysis, we're having to shift the data from NoSQL into a big data table, and that is cloud cost wise, it's expensive. So it takes computing power to. So imagine you're reading like 100 GB of data, writing it just to do analytics, and of course we have incremental backups and all that. All that is fine, but so the reason I'm saying this is uh, so we regularly try to, like, every 2 3 years improve the system a little bit. So our next step, maybe not now, maybe in a few years, will be to improve the database system, which we haven't touched since the starting of NPTEL or C. So in that, moving to SQL may be one of the options. Yeah. Yeah.
You spoke about programming assignments.
Yeah.
SQL, right?
Yeah. Yeah. Yeah.
Can you elaborate on it in a practical, like a technical aspect of it?
Yeah.
Are you able to integrate the virtual machine or compiler, interpreter?
Yeah, yeah, sure. So as I had spoken, I mean, the simplest way to do it would be you have a server, right, which accepts incoming code as a request, and you run it. So it might be hosted on a VM or something where, let's say, somebody gives you a hello world.py Python file, you run it, see the output, and return that. But then the problem there is security, because you're running code which has been submitted by somebody you don't know. So that's where this concept of sandboxing comes in. So you sandboxing is like having a virtual machine, a smaller, simpler variant of a virtual machine, where when you run something inside that, it cannot access the system outside its boundaries. So we use a sandboxing solution in a Linux VM, which has a REST API. So when you send code and some input test cases, output test cases, then the thing will spin up a sandbox, run that code inside, uh, pass the input as standard input to the code, compare the output, and return the results. So That way, the architecture is not complex when you look at it, but just figuring out what sandboxing to use, um, and fine tuning the parameters, because when you use a sandbox you also restrict parameters, like you restrict how much CPU the code is allowed to use, how much memory the code is allowed to use, and just figuring all of that out along with the scaling was a little challenging. Yeah, otherwise that's mostly it.
So the sandboxing you're talking about, right? The virtual machine. So you use some sort of a group, like a cloud computing aspect.
So we use cloud VMs for hosting our application, but the sandbox is done using this software called NSJail. It's a small sandbox tool provided by Google, released by Google. Yeah, I mean it's quite simple to run. You do NSJail and then space and then give it some parameters, how much memory you want to give, etc., etc. Give it your code to run. It will run it and it will make sure the code doesn't have access to anything else. So yes, yes. So the tech it uses primarily is Linux namespaces. Do you know about Linux namespaces? So it's a feature of the Linux kernel where you can make sure it doesn't have access to other processes in running on the same kernel, on the same system.
We use the same technology for system commands, virtual machine assignments.
No, virtual machines, I mean, at a high level, the concept is the same, but at a low level, it's quite different from what we use. So in virtual machines, you are spinning up a fresh kernel altogether. So this is sharing the same kernel. It's not using a different kernel. It's just restricting the access of the program. So the student program that's running, it doesn't have access to view or modify any of the other processes which are running, or modify the memory space of other processes. So it has a very specific memory address which it can access and modify. A virtual machine is a fresh kernel and it's much more isolated, but we don't need that much isolation for smaller things. Yeah. Yeah. Anything else? I will move on to the next part. Yeah. So my next topic I was going to address is what is the difference between when we uh, code for learning versus when we code to write for production, for example. I think the main difference is when, for me at least, is when I'm learning, I'm spending more time coding and less time doing other things. I'm just coding and observing. So if I want to learn a new language, for example, let's take Rust. Okay, I will pick up Rust. I'll pick up some random problem I want to solve. Uh, on one side, I'll keep the Rust documentation, or these days I actually use ChatGPT, so I'll keep ChatGPT. And on one side will be my editor. I'll just start asking questions with ChatGPT, write the code, run, see what happens. It'll fail, and repeat for some time. And one out of two things might happen, right? One is I might be successful in what I was trying to do, or I might reach a roadblock and have no idea what to do next. So when I reach a roadblock, then I take a step back, either watch videos or read documentation and just spend some time learning and then restart. So yeah, but mainly I'm just experimenting and playing around and seeing what happens. When I'm writing code for production, like when I'm coding for Seek or NPTEL or any of my earlier companies I worked for, most of my time goes in planning out what and how I'm going to write the code. So I would say maybe 20-30% of the time I'm actually coding. The rest of it is writing the algorithms or the business logic. And this is something I learned like the hard way over the years. Earlier, I would just jump into code and spend a few days coding just to see that, oh, okay, this is not going to work and I have to re architecture the entire thing. So these days, I spend more time just not with a pen and paper, but with like a notepad, writing down what I want to do, then visualizing how it will run or how it will work on the production systems. see if I can think of any edge cases which might come to my mind, address them, refine the algorithm, and then actually start coding. And I think apart from yeah, so I had written some points about how to plan better. First is, I think most important is figuring out what the objective is of what you're trying to develop. Sometimes there might be a bug you're trying to fix, right? You just know it's a bug fix. You know what is failing, but a lot of times we don't formalize what it should be doing. So just writing that down and having that in front of you while you think about the solution helps a lot. And the second aspect is, how do you know if your solution has worked? Formalizing that as well is very useful. So what that translates to directly is test cases. So even if you don't write automated test cases, it's good to write manual test cases. Like, once you've finished writing the code, how do you test it out? Write the steps down and have them ready. So they'll be at the back of your mind while you're writing the code. Even if you don't actually execute the test cases, you might pass them on to a software QA who will eventually test your code in the company. But it's always helpful to know how to test your code, because you're the one who's written it, and you will know best about where it might not fail. And yeah, so there's this interesting thing that I had was 70% of my time goes in planning and architecture, 30% goes in coding, and then another 100% goes in testing it. So just, yeah, I think most people just underestimate the power of testing, and people think that if you're a developer, you don't need to test. I think that's not. It's just that people who are purely testers, they don't code, but testing needs to be done by everybody. And the first step of testing is by you as you're writing the code. So it just makes it faster for you to fix bugs and improve it. Yeah, I think that was broadly the difference between production and learning. And so I have a small challenge for all of us. We don't need laptops. We don't need anything. We just need our phones. I will spin up. So I'll give the challenge, and then we can do some Q&A, some informal discussions. And then after like 20, 25 minutes, 30 minutes, we can see the results of the challenge. So this is to encourage the spirit of just experimenting and playing around with the devices you have at hand when it comes to coding. Yes, so this is called Phone of Fiend. So in the next 20, 30 minutes, you write an application which will crash your phone. Okay, it will hang, whatever, it will just stop working. Oh, it didn't open. It had opened. Yes. How do I? One second. Anyway. Yeah. So, yeah, the app should be written by you. I mean, you can use anything you want on your phone, doesn't matter. Uh, uh, Very important, you do this only on your phone, not on somebody else's phone. Any scary things like this should be only on your own devices. Yeah, it can be any piece of code you can run on your phone. Like, some examples are, it can be a JavaScript code that runs on the browser, right? Or it can be a terminal code that runs on a terminal on your phone. And yeah, just to define what a successful crash is, so that people don't end up bricking your phones entirely. It just needs to hang for like 3, 4, 5 seconds. Okay. And the phones we have right now are so secure that it will be nearly impossible to actually crash it completely. All of our code is running in sandboxes. as I was talking about, and you will mostly not have access to the system files. Which, before we get into this, how many of you all know about rooting or jailbreaking your phones? Okay. So rooting or jailbreaking is basically bypassing the security limitations of the stock phone software to gain access to the system. It used to be very popular a few years back to install custom software and make your phone do things which traditionally manufacturers don't allow. So, for example, I would jailbreak my long back. I had an iOS device and run Windows on it and stuff like that, which otherwise you can't do. There's no app to run Windows. Or I don't know if you remember, some 10 years back, iPhones did not have Bluetooth file transfer. So after jailbreaking, you would be able to do Bluetooth file transfers because you could install any app you want. It basically opens up the software to run whatever code you want. So the reason I ask that is if your phone is jailbroken, this is risky because then the phone security might be compromised. So, but then if you've jailbroken it, you probably know what you're doing. But so just be careful. If it's not jailbroken, it's fine. As long as you're not deleting any files, writing any files, it's completely safe. Your phone will restart and it'll work. Yeah. And so I have a demo which I will show on my phone after like 20-30 minutes. And the winning criteria is, yeah, so each person, I'll also show that. This is the standard open source disclaimer that comes at the bottom. Yeah, so each person gets 2 attempts to display. We will record the display and time it. Whoever's phone crashes the fastest wins. And I have a small device. Let me see. Oh, sorry. How many of you all know what a Raspberry Pi is? Yeah. So this is like a small single board computer, inspired from. Actually, I don't know whether this is inspired from phones or the other way around. So this has a small processor, very similar to the processors we have on our phones. You put in an SD card, you connect a USB cable for power. It has a mini HDMI port, and basically a full computer. You can connect a keyboard, mouse, etc., monitor to it. Start this, and you'll get a full computer, right? And very useful, very cheap. This is for 2,000 rupees, and not the most powerful, but you get more powerful variants for like I think 4,500 rupees, 4,000 ish. You'll get a computer which can do a lot. So for actually 2 years in the middle, I was traveling and experimenting with all of this. For 2 years, I was working on a Raspberry Pi. So I had like an iPad. I would use that as a screen and connect this and code on that, and it was fine. So yeah, I think the winner gets this. The criteria is it should crash faster than my phone crashes. So and then after we're done with the workshop, I'll show what code I wrote. You may or may not be surprised by how simple the code was and how easy it is to yeah, do such things. And yeah, I think we can start on that, and in the meantime, we'll do some uh, random Q and A's, informal topics, etc., etc. Firstly, anybody has any questions about this?
Can you give some brief of means we have only this Python and all
Yeah, yeah.
basically, so
So go with your strengths. Now you know how to use Python. Do a Google search or ask ChatGPT about how you can run Python on your phone, and start from there. Yeah, yeah. So we'll do 20 minutes first, and then 10 more minutes. Feel free to discuss among yourselves. It's completely completely okay. You can ask me questions, ask your peers questions. If you all want to do it in groups, it's fine. No rules at all. It's up. If you have not started with anything, let me know. I'll give some starting points. Otherwise, if you have already started with something, it's fine. Yeah, we have one person who has crashed their phone successfully. Congratulations. And we'll wait for it to get back to normal, and then I'll do a review. More minutes, then we'll just look at some solutions. I'll show you what I done. We'll have Bharat explain what he did, and go over the general concepts of uh, why this might happen in real life and etc. Time up. Anybody has any solutions which they have seen are working, apart from Bharat? Okay, no worries. So first, I think Bharat, can you explain your solution once, and also about how you thought about this and what made you believe that it would crash before you ran it? And
So basically, I use the OS module and I use the os.fork function. So using the os.fork function creates a new sub process. So I just created 10,000 new sub processes, and that just overwhelmed my phone CPU.
And if I would ask you why this would not be restricted in a sandbox, what would your answer be?
Because okay, I don't know exactly, but what I would assume is being happened is since I'm using the OS module, I'm like directly tapping into the phone's processes, and I'm directly creating new processes. So that might come outside of the sandbox, or it might expand the sandbox beyond its limit. Like it might increase the limits of the sandbox to the phone's capacity.
So that's not entirely what's happening. So what happens is most of the sandboxing that happens, right, is process specific. So when the OS limits its resources, it's per process. So if you spawn 10,000 processes, each of the process has its own sandbox. And of course, this is comes all under the application that's running it. So PyDroid or whatever you use to execute it, that will have its own sandbox, but that is a much wider sandbox. So it gives the code some few seconds to cross its limits, and then the OS will kill the app. So I did the same thing from my phone, but I think it's just taking longer to crash. So might be the thing I use. So everyone, I show the code that, so both of us wrote very similar code. So I'll show the code that we wrote and explain it. But before that, thanks, Bharat. If,
I still don't understand why it wouldn't just crash only the sandbox. And why does it crash the entire UI of the system?
Yeah, so that I think is so in my phone's case, you saw that the UI restarted, which is what should happen. It should not stay crashed until you restart the phone. I think that's just a different way our phones are handling misbehaving applications. So what your phone is doing is letting you restart it manually, but it's not automatically restarting. My phone is automatically restarting. I think that's the only difference. Ideally, it should not happen, but nothing is like 200% secure. So yeah. Yeah, okay. Thanks, Bharat. Yeah. So before we go into the code that we actually wrote, I'll just go over how you can actually code on your phone. Like some people here would, I think, want to know a little bit more about that. So ultimately, our phones are computers only. They just have a different user interface. They're all Linux kernels or Linux operating systems running on our devices. And they have a little bit more fine-grained security control than our desktops. So traditionally, phones are not designed for running code, right? So that's why it's a little difficult for you to get an editor or a platform where you can actually code and run. But once you do that initial research, you install something which lets you run some code. It's the same as using a computer. It's just a small screen. In fact, if you really want, you connect your phone to a external display, connect a USB and mouse, and once you're inside your editor, it will not feel any different from your computer, right? So yeah, so step one would be to get an editor and a playground where you can run code. What is your name, sir? Rahul, right? Yeah. So you were asking me how to run code, etc. You haven't done programming earlier. Yes. So to do this, I would say I would wait until you learn a little bit of programming, because this might feel a little overwhelming if you don't know coding at all, right? But let's say after 1 or 2 weeks of coding, you can try it out on your phone. Just Google search how to run Python on iOS. Once you know a little bit of Python, it'll all start making sense. You'll get an application where it'll give you the same screen that you see on your computer. And then it'll make sense and you'll be able to run some code. Okay, and it's just a good thing to have in your pocket, right? You're traveling, you're bored, take out and do some coding. Yeah, so that was one side of it. Second is the theory of uh, when an application might actually hang your system or crash your system. Uh, we'll go back to the theory of sandboxes we spoke about, where it's limiting the resources. So most well-designed applications, if it's letting you run your own code on it, it will have some sort of sandboxing, right? It will not let you do whatever you want with the system. Otherwise, it's fairly insecure. So, uh, yeah, sandboxing is basically the system memory, the CPU resources, and these are the two primary resources used by a computer, memory and computing power. Hard disk space is another one. I have written code which just fills up the hard disk, but that is uh, not the cleanest, because then if your operating system stops working when your hard disk is full, how do you delete the files, right? So, so then back in school or something, I would just write a program which would write garbage data onto a file in the C drive. And after 10, 15 seconds of it, my computer became unusable. So then I don't remember how I did it. I probably booted up with another operating system or something and deleted the files. And then I could use it again. So all that I would say stay away from. When you're hacking around, do things which are reversible easily. And yeah, so that leaves us with RAM and CPU. Going in any direction would work. If you, some of you are doing a stress test, right? So most stress tests are designed to test the limits of your CPU, not to exceed it. So you would have to fine tune the stress test a little bit so that it explodes, not just. So when you're testing the limits, you go slowly, right? You go to 10% CPU, see how much it works, 20%, see how much it works. Here you want to go like 10,000% in one shot. So you would have to make those changes. And for RAM, I saw some of you were allocating memory to variables randomly, which is also a great approach. But in both of these scenarios, it gets caught by the sandbox. Right. The sandbox will detect that the memory or the CPU usage has gone up and then kill your application. That is where the forking method comes into play, where most sandboxes check a single process, not multiple processes together. So each process has its own CPU limit, memory limit. So if you spawn infinite processes, then that's a very quick way to mess up your system entirely. And yeah, I'll just show the code that we wrote, and then we can. That is essentially what we did. So you had a limit on the while loop. Doesn't matter. I mean, it will crash way before it reaches 10,000. Yeah. So, and os.fork is basically creating a new process in the operating system. And yeah, I think once the number of processes reaches beyond a certain limit, the system struggles to control it. If we go into how we would prevent this from happening, like, so right now we were proactively trying to crash the system, right? When, for example, the programming assignments, I have to deal with such cases so that if somebody submits this code on our system, it shouldn't crash the entire VM. So then we limit the number of processes you're allowed to spawn. But I mean, I knew that Android doesn't do that. So this is a very easy way to, yeah, that's it. So I think that you will get a Raspberry Pi. Have you used one of these earlier? Oh, very good. Very good, great. This is a Pi Zero, so it's one of the smaller variants. Try it out. I will send you, I should come here. Yeah, I will send you some resources which might help you get started with this. In fact, I'll share it with everybody. So this is basically a small, I spoke about this, right? Single board computer. Very good for hacking around playing. You can install multiple types of operating systems on this. So it supports an SD card, flash it. And this is like your personal small assistant. Wherever you go, play with this. It's a lot of fun. Yeah, all of you can, if you want, you can just get one of these and play around. And yeah, traditionally this needs a monitor, etc., but there are ways to use it by using your phone as a monitor. So I'll just share links on a basic setup of this, and congratulations. Close. Yeah, thanks everyone. Thank you for coming. This was a great time. Hope you all had a good time. And yeah, I will share this code. Run it anywhere you want, don't run it on our platforms. Not that it'll break it. It should not break it, but in case it breaks, it'll be my headache. Yeah, and I'll also share some of the Raspberry Pi links. If you all want, you all can experiment. And cool. Thank you, everyone. Have a good day.
Appreciation we are having. Yeah. So I've been with Rishav for I think now 8 years. Yeah, easily 8 years, and it has been fantastic knowing him. Oh, I mean, he is my first podcast guest, which we'll be releasing out shortly. So we are interviewing a lot of people as part of the program, and we are trying to show the different paths people have taken, both at our side as well as the student side. This will come out, and some part of what he touched upon today, being a programmer, being more inquisitive, trying out things, hacking out things. That's what typically programmers do, and I urge all of you to try tinkering a lot. I mean, that's how you will learn. In fact, if you remember when you were pre-KG, you would have tinkered around soil, you would have tried different kind of combinations of food with sand, with other kind of things. So that instinct is there in all of us. Only thing is the medium becomes different. I mean, some of you may do on computers, some of you may do on very tangible hard devices. Some of you may tinker on more conceptual ideas like the quantum physics and other kind of things. Everywhere asking right questions, trying to figure out where the border is and trying to push that barrier. I think that's what key to learning is. And thanks Rishav for giving us a fantastic demonstration of hacking stuff and and still making sure that things work. I hope, yeah, so all of you who are doing, how many of you are doing OPPs here? Did Rishav tell you that he built the engine? Okay, so the other thing that Rishav is doing right now, and this is generally for everyone, is He's trying to create a Seek which can run without any, on top of your OS without you doing all tabs. So you will not permit all tabs, it will not permit anything. You will not be even able to do WhatsApp chat or listen to people and type. So that kind of examination system is what Rishav is currently working on. And if that comes in, I hope a lot more of our exams will be more secure, and overall the program will also benefit. Rishav otherwise is available in GitHub at Rishav T, and I don't think, don't reach out to him in social media handles. GitHub is the best place to ping him, and yeah, and email, of course, Rishav at nptel.iitm.ac.in. If you guys have more interest, and he's a good mentor. If you want to try out new projects, do reach out to him. He's a good resource to tap into. Thanks, Rishav, once again. Yeah, thank you. Bye.